What's up, guys? This is Coach Castile. Today I'm going to talk about an interesting side note of the trig ratios called the law of sines. Now, the law of sines extends our trig stuff not from just a right triangle, but to any triangle now. So here's the deal. The law of sines only works for three specific cases, and we'll talk about those specific cases in just a minute, but let's just first understand how to set it up. And what it is, the law of sines is a ratio, or a set of ratios equal to proportions. So what it is we take any angle and its opposite side and make it a ratio. So we'll say the sine of angle A is to its opposite side, A. So the sine of angle A is to its opposite side, A, as the sine of angle B is to its opposite side, lowercase b, as the sine of angle C is to its opposite side, lowercase c. And that will work on any triangle, regardless of angles, in three specific cases. Now, this first video is only going to worry about two specific cases. The first one we're going to talk about is when I know the two angles. This is the two angles law of sines. So either angle, angle, side, or angle, side, angle we can use to find the missing angles or sides of any triangle, regardless of whether it's a right triangle, obtuse triangle, or acute triangle. Now, this second one, side, side, angle, we're only going to use in specific cases, but we've got a certain caveat to that one. This one is going to lead to what's called the ambiguous case. And the ambiguous case is a little tricky. We'll work on it separately, and we'll do it on another video. But for right now, side, side, angle, we're just going to leave it out and do only the two angles, okay? So anytime I have two angles and a side, whether it's angle, angle, side, or angle, side, angle, I can use the law of sines to find the missing side, all right? So let's look at this example right here. Find all the unknown measurements in the given triangle. Round to the nearest tenth. Well, first off, I'm missing angle A. Well, guess what? Angle A is about the easiest thing you can find, because guess how many degrees are in a triangle? You guessed it, 180 degrees. So to find angle A, I'm going to say it's 180 minus 42 minus 28. And I'll get my handy-dandy calculator out right here. Do 180 minus 42 minus 28. And we come to find out that angle A is 110 degrees. So I've got a 110 degree, 42, and 28 degree triangle. So now let's use all the information I have here and let's set up our law of sines, okay? So let's start with angle A. So we'll take the angle, the sine of the angle, the sine of 110, over its opposite side, which we don't know, so we'll call it A, is equal to the sine of B, which is 28, so the sine of 28 is equal to its opposite side, 8, as the sine of C, or the sine of 42, is to its opposite side, C. So remember, these are our angles. Angle A, angle B, and angle C. So let's start out with side A. We've already found our missing angle. It's 110 degrees, and we did that without any hard trig. So what we're going to do now is we're just going to use our main solving proportions by cross multiplying. So here's how it goes. We'll take the sine of 110, multiply it by 8. I always put the number first, so I'll do 8 times the sine of 110, there's cross multiplying that way, equals A times the sine of 28. And there's the first equation I have to solve. Okay? So, now that I've got my equation, we're going to solve for A. So remember, the sine of 28 and the sine of 110, they're all numbers. You put sine of 110 in a calculator, it's going to give you a number. You put the sine of 28 in a calculator, it's going to give you a number. So basically, it's just like a simple one-step algebraic expression. We're going to solve it. We're going to divide both sides of our equal sign by the sine of 28. Divide this side by the sine of 28. So, right there, 8 times the sine of 110 over the sine of 28. On this side, the sine of 28 divided by sine of 28 cancels because it's something divided by itself and equals 1. So all I have left here is I have A equals, now it's calculator time. We want to do this in pieces, okay? So what I want to do first is I want to start out by doing 8 times the sine of 110. So here I go. 8 times the sine of 110 in my calculator gives me 7.5175. Ding, 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 whatever's the rest, okay? Now, since I've already got that in my calculator, I'm just going to hit the divide button, and it'll take the previous answer, and now I'm going to divide that by the sine of 28, and that leaves me my A is 16.0. So my missing side opposite of angle A is 16.0 units. So there's my first piece of the puzzle. Well, actually, the second piece, because the first piece was we found the missing angle, 110 degrees. Okay, well now we've got another missing piece. We've got to find this sine C. So you got two options. You can either use the new 16 that you found right there and do the sine of 110 over 16 equals the sine of 42 over C and solve it the same way, or since we've already got them here, let's just go ahead and use the sine of 42 over C equals the sine of 28 over 8. So we're going to cross multiply this way. The sine of 28 times C is C times the sine of 28 equals 8 times the sine of 42, 8 times the sine of 42. Just like before, we're going to divide both sides by the sine of 28. Divide this side by, the sine of 28. Okay? So the sine of 28 over the sine of 28 cancels and gives me 1. So that's left C equals, and then I'm going back to my handy-dandy calculator here, and I'm going to start out with the top. 8 times the sine of 42 gives me 5.35. Keep on going. Take the result, so you just hit the divide key, and it'll take the previous answer, divide by the sine of 28, and I get 11.4. So there's my missing pieces. I've got side A is 16, side C is 11.4, and angle A is 110. And that's the law of sines, guys. It works best for angle, angle, side, angle, and side, side, angle. Now, we'll talk side, side, angle again tomorrow, but let's do another example, okay? Let's do another example, all right? So let's look at this one right here. On this one, I've got triangle PQR. Don't let the P, the Q, and the R get you down, because here's the deal. For PQR, you just take P and its opposite side. So if this is capital P, its opposite side is going to be lowercase p. If this is Q, this one will be lowercase q. And angle Q, if you don't already know, well, if that's 30 and that's 60, this has to be 90. But guess what? The law of sines will still work, okay? The law of sines will still work. So here we go. So let's start out by doing the sine of 30 over 15. Angle sine of 30, opposite side 15, equals the sine of 60, angle over its opposite side, P, equals the sine of 90 over Q. Now we know it's a 30, 60, 90 triangle, and we know this one will be the short leg, so that means that our long leg is going to be 15 square roots of 3, and our hypotenuse is going to be 30. But let's just double check it using the law of sines here. So I'm going to start out with side P, okay? I'm going to start out with side P. I'm going to take my cross multiplication, P times the sine of 30. So P times the sine of 30 equals 15 times the sine of 60. So P times the sine of 30 equals 15 times the sine of 60. Okay? We're solving for P, so I'm going to divide both sides by my number, the sine of 30. Divide this side by the sine of 30. Those sines of 30 cancel out, and I've got P equals, okay, it's calculator time, and I'm OCD, so I'm going to clear my calculator out here. I'm going to do 15 times the sine of 60. That's my top. Just leave it in the I've got 12.99 repeat, or whatever. Take that result and just hit divide, which is the previous answer. Divide by the sine of 30. Do that in your calculator, and you get 25.98. Okay? So if we're going to round that to the nearest tenth, well, the tenth is a 9. That would have to just kick it up to 26. Okay? So there it is. P is 26. All right? P is 26. Now, let's talk about finding Q. So for Q, I'm just going to go back up here, and I'm just going to use the sine of 30 times Q. So I'm going to cross multiply the sine of 30 times Q. I'm just pretending this middle part isn't in there for right now, so I'm going to cover it up. The sine of 30 times Q equals 15 times the sine of 90. So the sine of 30 times Q is equal to 15 times the sine of 90. Okay? Again, divide both sides by whatever number is left of the Q, or the letter, the sine of 30. Divide by the sine of 30. Sine of 30 over sine of 30 cancels, leaving me just Q equals, and now I'm going to do it in pieces. Here we go. 15 times the sine of 90, close your parentheses. Hey, that gives me 15 because the sine of 90, opposite over hypotenuse of a 90-degree angle, is 1. Take that result, divide it by the sine of 30. Now we already know it's going to be 30 because it's a 30, 60, 90 triangle. Guess what? There it is. Missing side is 30. So that's the law of sines for the two angles, either angle, angle, side, or angle, side, angle. On the next video, we'll do the ambiguous case for side, side, angle. And I hope to see you then. Goodbye.